So this is April 14th and the 7 a.m. Western Automation Technical class. Welcome. Today we have a guest speaker from Turck, a gentleman by the name of Eric Krause. And the subject is an important one. It is the equipment to network I/O for automation systems in the industrial world, as we supposedly bring manufacturing back to the United States. If we want to keep it here, we have to automate, because nobody in this country works for $500 a month. And with that brings opportunities for the subject matter that Mr. Krause is going to talk about. Now, this is a technical class, but we do clue you in on products that you use for the applications that we speak about. We are honored to have Mr. Krause as a guest speaker today. And with that, Eric, you've got the floor.
All right, sounds good. And yeah, thanks everybody for getting up and getting on your computers early this morning. I know it's even a couple hours earlier out there than it is here. So, but yeah, so it'll be a bit of product today because I'm talking about something that is pretty much only something that Turck is doing right now, and it's something that we've been waiting for a long time. This has to do with our safety offerings, and let me share my screen here. All right, let me know when everybody can see this.
You're on.
All right, good deal. So, this is something we talked about really early in the release of these safety blocks, the Turck TB-IPs and the TB PNs. So these came around, it has to have been about 4 years ago. It's kind of our first offering for safety and getting into that market space. But traditionally, we've had these safety blocks that operate either on SIP safety or ProfiSafe. Two different part numbers depending on which one, because TUV wouldn't let us do multi-protocol at the time. But something that we talked about early and really haven't talked about in a long time, but kind of long awaited, is what we call our Turck SafeLink. So traditionally, you would need a safety PLC in order to communicate safely with these blocks to a control system, or more importantly, network more than one block together, right? So we do have standalone capabilities on these blocks to do safe functions via our Turck safety configurator. But you've always been limited to just the I/O on the one block. There's never been a way for blocks to communicate safely to each other without the use of a safety PLC. So safety PLCs, once those get in the system, they're a bit more expensive. So this technology called SafeLink essentially allows us to make networks of blocks that are all talking to each other, exchanging safety I/O, but without an actual safety PLC on the network. So yeah, very modular design. Like I said, SIP safety and ProfiSafe were the first technologies we dealt with. These new blocks were doing L code power, so you get a little more ampacity, up to 16 amps. This is something we're only doing on the full safety block as of this time. So just a refresher there, you got 8 ports of I/O. You got 4 safety input ports, and then 4 safety configurable ports. So when splitting up channels, of course, if the max safety level isn't needed, you can get to 16 single inputs. Or, of course, the max with full safety, 4 dual safety inputs and 4 outputs. So a really cool thing we're able to do here is we can now use multi-protocol on these. So rather than being a TBIP or a TBPN, it's now a TBEN as our standard is for multi-protocol. And with SafeLink, now you can make a network. You can take one block, one safety block, and you can network up to 31 more blocks and create just a big safety network. And most importantly, if it's not needed, you don't need a safety PLC. Everything's communicating between the blocks safely, and you can report it back to just a standard PLC, just for diagnostic purposes. So I kind of already covered this. Little refresher though, we got the 4 safety input ports. We got the configurable ports on the right-hand side. Ethernet IP, SIP safety, Profinet, ProfiSafe, standard embedded switch, M12 decoded, and then of course where you can do your addressing. And we also have a little memory chip. I'll show a little better graphic of that. So here we can get to a network where we just have, say, a standard HMI PLC. We have some safety devices, we have some standard devices, and everything can sit on that same network without the need of safety PLCs. At the same time, another thing to bring up is the TBSB safety shutoff devices, passive safety. A lot of times the real high safety standards aren't needed. Safety by power removal will suffice in a lot of instances. So we see a kind of a network built up like this. So basically we have feed through power through the power bus of the IO blocks. Then we have a shutoff device with a safety relay. And then optionally, based on safety level requirements, also a EDM feedback loop. So we're monitoring through a standard input the state, the transitional state of the relay inside that box to gain a little higher safety ratings. And downstream from that, can be an IO link master, it can be standard IO blocks, it can whatever, right? We're going to remove the power from the power pins of that IO block to turn off the outputs. A little more to it when it gets into IO link with Class A and Class B and how blocks are set up. Of course, with our Turck blocks, we have Class A on one side and Class B on the other side, which are on separate power groups. So in the case of this graphic I'm showing, we can shut down only the Class B side of IO-Link. And I think this is probably pretty standard on other blocks too. But that way we can keep all of our communications active with the block, with the IO-Link devices even, but we're just removing the output power from the block or the downstream IO-Link devices.
Eric, can you talk for a second a little bit about the difference between Class A and Class B, maybe wiring and?
Absolutely, yeah. So Class A IO-Link and Class B IO-Link, it's an M12 specification where because a lot of devices in the field now are starting to get a lot higher power capabilities. Take, for instance, in this graphic, we have an IO-Link hub, which is capable of 2 amp outputs. Traditionally with IO-Link, you have your power on pins 1 and 3, and then you have your IO-Link on pin 4, and then just a standard input or output on pin 2. So in the case of traditional IO-Link wiring, that means you only have a single power group, depending on the port, the device, whatever that you're plugged into. It's limited to a max of 4 amps. So once we start looking at high amp outputs, that can get used up real quick in the field. So we need a method to basically allow for higher power devices. And that's where Class B comes in. So Class B uses that pin 2 as well as the pin 5 on the M12 cord set as a completely isolated secondary power group. So that way you can feed in a whole nother power supply into the block, another 4 amps. And that will get you a lot more ampacity in the field, especially when we're dealing with these 2 amp hubs, things like that. At the same time, like I said, those are completely isolated power groups. So in the power connector, we have 2 power groups, power group A and B. And the secondary power group is specifically for the Class B IO-Link. So that's why that's what it's kind of depicting in this graphic. We have a safety shutoff box. We're removing power only from the output on the IO-Link devices. So when somebody hits that e-stop, we can still communicate with the IO-Link master. We can still communicate with the IO-Link slave, but it just strictly won't have any output power. Another example would be valve banks. Those are getting on IO-Link now, and they tend to need a bit of extra juice, you know, depending on how big the stack is. So yeah, it's kind of Class B for you there.
Thank you.
Yep. So this is something we've always had, but it's a nice advantage if you do have a block that fails in the field. We have a memory chip that you can unmount, put into the new block, set the IP address, and it can just go. So that way you don't need to have a PC to replace these. You can also duplicate these, things like that, for faster block commissioning when you have a bunch of blocks that operate with the same programs in them. There's a couple different ways to do it depending on whether you're on Profinet or Ethernet or SIP safety. But yeah, so generally just another easy way for block replacement. So kind of the last part that we're waiting on before we can do a formal release on these, I should come out and say these aren't formally released at this point. I've seen these working. We have devices and beta software at this point. So the last piece of the puzzle is the new version of the Turck Safety Configurator, which is going to allow the configuration of these safety networks over SafeLink. And that's coming real soon. So yeah, we're all really excited to see this come out. The hardware is already complete all the way through TUV, ODVA, all the governing bodies there. So yeah, we're right on the cusp of the release for this. So
that's just for the new one, right, Eric? I think it's worth noting that the Profinet and ProfiSafe are out and are released.
Absolutely, yeah.
I think I may be speaking out of class here, but I think they're both in stock.
Yeah, generally we've been able to keep our stock levels up on those as well, depending on, you know, unforecasted usage and all that normal stuff. But yeah, we have a bunch of different variants. Of course, we have different power connectors, as 5-pin mini is a bit more common in Europe, whereas 4-pin mini is more common here in the States. And then of course we got the L-coded M12 as well. On top of that, we have the Profinet and ProfiSafe variants, which are two separate parts for our traditional blocks here. And then we have both a hybrid version and a full safety version. And I should have probably went into that a little bit more, but just to show you a picture of kind of what they look like. Of course, red for SIP safety and yellow for ProfiSafe. And I don't have a lot of good slides on the hybrid for this one, but essentially with the hybrids, we're dealing with 4 safety ports, which 2 of them are dedicated inputs and 2 of them can be configured input or output. And then on the standard side, we have 2 just standard input or output. So we call them DXPs at Turck, discrete configurable PNP. And we have 2 channels in each one of those top 2 ports. Each one can handle 2 amps on the output side. And then the second 2 ports on the right-hand side of the block here are IO-Link masters. So same port layout as any other IO-Link master we have at Turck, where we have our pins 1 and 3 as the power. We have pin 4 as IO-Link, and then pin 2 as a DXP. So this is just Class A on the blocks.
Hey,
one
Eric,
thing to note, no, go ahead.
Keller here, quick question. When you make it a 2-port, you have to put a splitter on one of those. Is that correct?
Yes. Yep. If you need to break those out to 2 separate M12s, it would require a splitter similar to our standard, say, 16 DXP block.
Mm-hmm.
And one cool thing to note about the IO or about this hybrid block in general is the fact that we have what's called our safety shutoff bits that are internal to the block or to the circuit board. So within the safety program, based on the state of, say, a safety input, we can remove power from these top two ports with one of the shutoff bits, what we call FS0. So it just shut down these two ports, or the secondary IO link port. So it kind of goes into that power removal state again, but we have put some of that internally in the block. And yeah, these have been released for years now. Like Chris said, they're generally in stock in one variant or another, and yeah. So like I said, these have been around. The SafeLink stuff is something that we talked about a lot at first as kind of roadmap stuff with these safety blocks, and then it kind of just went silent for years with everything that was going on. And now we're kind of back into that with this second generation of safety blocks. So yeah, there's within the safety communication between these blocks, there's an amount of SafeLink bits for each device, similar to how we had SIP safety or ProfiSafe bits for our standard safety blocks. And then there's also field bus bits. We've also had this on our standard blocks, but instead of just going straight to a PLC, these can be exchanged throughout the blocks. And then, of course, we have a bunch of diagnostic information that comes back with these as well. So anything from, wire break or cross channel, faults where, say, your force guided input, like a safety push button, as it has two contacts in it, if those don't transition within the correct time range, that'll also fault out the block, go into the safe state, get some more diagnostic back into the PLC. So your PLC still has full monitoring capabilities, even though it's not talking to them over a safe communication and controlling them over safety. So that's all being done standalone. So this could be nice for those maybe smaller machines or even modularized type machines where they might not be big enough to the point where some of the OEMs would want to put a safety PLC right on it. But yet they would need more than what we could offer on a single safety block. Maybe the end user where the machine is going has a safety PLC, but and maybe is monitoring some other safety devices. It can still read in these blocks in that same way as well. So yeah, quite a bit of flexibility with these, and being able to network these without a safety PLC could be a big cost saver for the customers. So, and looking into the future a little bit, I'm sure maybe some of you are familiar with our multi-protocol spanner. That is built into a standard TBEN standard IO block. I believe it's just our 16 input block, and then also our little FEN20. So it'd be basically an 8DI. But the spanner that we currently have and have had for quite a while, it's kind of a problem solver device. It allows you to bridge the gap between protocols of two different PLCs. So kind of in a nutshell, how that works from a technology standpoint is we have our two ports on the IO block, and each one has its own IP address. So it's not just your standard embedded switch. And what happens is when you connect a PLC to the port, you connect one on each side. So each PLC has an exclusive owner to the block. And basically what our block is doing is just taking a full data map, a full SIP packet, I think 480 bytes of data, and it's just swapping that. So basically output data from one PLC becomes input data to the other PLC and vice versa. And our block can convert those protocols. So if you have an Allen Bradley PLC that needs to talk to a Siemens, you can put this in between it, and it can exchange that information. So the idea here with the safety spanner is to say, hey, okay, well, we did this with standard Ethernet. Why can't we do it with safety IO? So this would allow two safety controllers to communicate safely between themselves over two separate protocols. So it could bridge the gap between SIP safety and Profi safe. This is just a potential functionality that we're looking at. So it's a little early for me maybe to even talk about this. It's probably not even on the roadmap, but I saw this slide and I'm like, well, that'd be really cool. So I figured I would bring this to you guys too. And that's all I have on the safe link. Any questions on that? Good to go? All right. All right, let's see, which one am I looking for here? Okay, so the other thing I want to talk about here as well, or another one of the things, is just standard in-cabinet switches, the TNICs, which are we just released at Turck. We've had switches for a long time. They've been very simple, traditional switches. Nothing really, nothing too much to write home about. Plastic cases, all that stuff. So we've come out with a new switch now. Really nice looking switches. I got a chance to see one of these. I haven't got my sample order from it yet, but this will be our new offering. So much more compact, much smaller footprint. We got a full metal housing on it. So a lot more robust and also a much wider voltage range. So of course, space in the cabinet always comes at a premium. So having a smaller footprint, we can hopefully free up some of the space in the customer's cabinet. Once you run out, it's not easy to get more. So cost efficient. These are much better priced than our last switches. And of course, with flexible power supply options, we can deal with 12-volt systems, 24-volt systems, you name it. And we got a few different variations of these. They're all unmanaged for now. We have 5-port, 8-port, 16-port, and standard 10100 megabit. And then we have a 5-port and an 8-port gigabit switch. So as we've done with our block IO, we're starting to get into the gigabit world with our switches. So that's becoming more and more of something we run into in the field nowadays, especially with camera systems, things like that.
Eric, quick question. Could
Yeah.
you do just a real quick explanation between managed and unmanaged?
Oh, sure. Yeah. And I'll be showing, I'm going to get into our block switches as well, just because it's something that's been out there, and I'll get a little more into that. But yeah, standard switches, standard unmanaged switches, they don't have an IP address. They're basically there to take traffic and forward it to the proper device. So there's no way to actually connect to these. They're just storing and forwarding data on the network. So as opposed to managed switches where they have all sorts of different functions to help with traffic bandwidth, things like that, NAT routing, firewalls, and all the fancy stuff you see in those. So, and I'll get into that a little bit more because we have our TBEN managed switch that really has a lot of functionality in it. So you can kind of see here that we had our traditional switches; those have been around forever. And yep, this is the new streamlined design. Of course, these kind of go everywhere. There's no specific market, right, for an unmanaged switch. But yeah, these will kind of sit wherever you just need some more Ethernet ports. Of course, small automation cells with cabinet space restrictions, things like that. HMI panels. Yeah, I'm sure you guys have seen plenty of unmanaged switches in the network, so you don't need me to tell you where they go. And yeah, that's kind of all I have on these IP20 switches. But yeah, something new and just something that I recently saw that just is a really, really nice switch. When you hold it in your hands, you can tell the quality, right? So any questions on that so far? All right. TBENs are IP69K switch offerings. So we have these in both managed and unmanaged. So this is a standard unmanaged switch. So this basically acts the same as the standard switches I was just showing you. Except of course it's meant to be hung right out on the machine in the elements, dirty, wet environments, whatever. It'll hold up to that stuff. This, unlike our managed switch, this doesn't have gigabit on it. This is just standard 100 megabit. So 8 standard ports. It's actually, if you look at it, it looks the same as our other switch, just without any rotaries or any gigabit ports on there. So IP69K, negative 40 to 70, just kind of like all the rest of our blocks in our portfolio. Nice voltage supply, so flexible there, 8 to 30 volts. So if you end up running into any type of mobile equipment, things like that, we're going to be able to operate on those voltage levels. No web server, no IP address, no configuration. Like I said, it's just a standard switch. So it's just routing data to devices over a network.
Eric?
Yep.
Chris here again. Do you still see majority being 7/8 mini-fast power connection, or is there more and more L code being sold or used?
I'll say there's more and more L code, but still in the US here, 4-pin mini is by far what we see most often. But
Okay.
yeah, L code has really made a jump here in the last, I'll say even like a year, I think that just goes along with, it all kind of got pushed by Germany or I won't say Germany, I'll say Europe. And now it seems like now that the devices are all coming out with L code, it just feels like people are adopting it more recently. So, and it has
It's even
benefits, being able to get that much more ampacity out of it is definitely a benefit. With higher power blocks, if you're using it, bus in, bus out on the power ports, having extra ampacity is really big because if you're running blocks with those 2 amp outputs, it's gonna eat away at that max power we can do through a mini fast pretty quick. So
got it. And then also what I just want to note really quick, I'm sure most people know this, but the color coding on the ports here, so the green or the teal indicates the Ethernet, where Profi Safe is the yellow, right? And Rockwell or Allen Bradley Safe, the SIP safety would be the red markings on the connections, correct?
yep, absolutely. So yeah, this essentially matching the teal cable jacket color of Ethernet IP. So, but I'm not sure if we have, in Europe they have for Profinet they have a lighter lime cable jacket. I'm not sure if we have a version with that or if they do in Germany, but yeah, that'll have to be something I maybe check into. It may be that the ones they ship to the US have the teal ones and they do the lime green in Germany. I don't know. So here's a little bit managed versus unmanaged. I'm glad I left this slide in here because I've already had a question about it. So unmanaged switches cannot be configured and have no IP address. It basically operates on the MAC layer. It learns the MAC addresses of the connected devices and dynamically forwards the packets only to the devices that they're intended for That way it's not being broadcasted to all the devices. It forwards all broadcast and multicast data packets. So unlike a managed switch, you can't control that broadcast flow on your network. So basically, it does give the potential to flood the network, right? If you have a bunch of devices broadcasting data everywhere, you're not going to be able to restrict that via an unmanaged switch. Cannot forward data packets between two IP networks. So essentially, as it's always been, for one device to talk to another device, they have to be on what's called the same IP subnet. So in the case of, say, 192.168.1, those first three octets, at least with a 255, 255, 255 subnet, they must match those first three octets. And then, of course, the last octet be unique on the network. So it would not be able to bridge the gap between two subnets. And again, that's where managed switches will come in. No security functions, no monitoring functions, no redundancy functions, but of course are a lot less expensive than managed switches. I won't say a lot, but enough, I'll say. And onto the managed switch. So each port has its own IP address in the case of a managed switch. Security functions, so user management, firewall. You can disable ports. Firewall rules can be set to only allow certain IP addresses into a network and reject all other packets, things like that, even down to just standard TCP ports. So can reduce broadcast storms and can forward multicast data packets to the correct subscribers. So basically it can figure out what devices are meant for the broadcast packages, or multicast packages, I should say, and only send them off of those ports. Can forward data packets between two IP networks, such as your machine and company network. Some people would call it IT and OT. I think that's the big terminology nowadays. But essentially, it's network address translation, or NAT, IP routing, things like that. So basically, you can have your internal network, your machine network, and let's say very basically, maybe a computer on your outside network needs access to, say, a web server of a TBEN or something. You can basically tell it, okay, transfer these packets over to this device, but only on this port 80, which is the standard port for a web server. Sometimes 8080. Of course, there's a bunch of redundancy functions built in. I have a couple slides on that. You can assign addresses to network subscribers, and when they say network subscribers, it's basically just IO blocks or IO devices on the network. So port-based IP address allocation. And with our newer managed switches, I'm sure this is different from vendor to vendor, but we can actually, we've created EDS files and GSDML files for our managed switch. So you can actually map it to a PLC and get process data back from the switch about what's going on the ports. So that's something new we've added, within the past year, I think. So all sorts of different stuff. I'll kind of rip through this slide, but here's a picture of our managed block. So unlike the unmanaged, it has these two ports here, and these are the gigabit ports, and all the rest of these ports are 100 megabit. So essentially, you can run at what they call wire speed, right? Which means every port is up and operating at 100 megabits, and all that data can be transmitted through your 1 gigabit high-speed backbone. So no network latency when you're running at wire speed.
This one looks like it's got your lime green, Eric.
Yep. This is the lime green I was talking about, and it popped into my head when you mentioned the teal, because I've never seen one actually with lime green, so I'm not sure if that's something they do more in Europe, or they just have it like this on the PowerPoint. But yeah, it's lime green is the Profinet color coding. standard, where teal is the Ethernet IP. So I should note that they both work the same and are the same. It's strictly just different colors. So
Is there a like power over Ethernet version of these on the roadmap?
not that I'm aware of. It's something we've maybe talked about. I mean, we've been having PoE discussions since I first became a BDM 8, 9 years ago, but it's always been a matter of power limitation, when it comes to IO blocks and things like that. I know with the switch, it's not as for us to develop it. I guess it wouldn't be as much of something we would need to look at as much as an IO block and putting PoE on that. So I'll say that I would say it's definitely a possibility in the future, but I haven't heard much chatter about it at this point. So yeah, this is just kind of a little list of some of the things it can do. I've kind of already went through a little bit of this, but network load monitoring, frame prioritization, stuff like that. I'll jump into that on these next slides. Yeah, it's a pretty daunting list of functionalities that are on this. We handle both layer 2 and layer 3 type managed switch functions. So your layer 2 getting down to your NAT and things like that. So, but yeah, web-based management. So it has a web server, which is really nice. That's not something you get in all switches nowadays. Quick link up, firewall, network load monitoring is cool. I have a graphic of that as well. And that's the kind of stuff we're going to be able to monitor over the EDS files and things like that. NAT routing, VLAN, prioritization. Of course, it supports Profinet. Inter VLAN routing. A lot of switch terminology here, which is something that maybe a lot of us don't get exposed to as much because it's more of an IT function than your OT function with what you see on machines and things like that. So I'll get into option.
Curious about cable diagnostics.
Oh, cable diagnostics.
Are you
Yeah.
familiar with that bullet? My attention.
Yes. So that goes a bit beyond just redundancy. It's more of I'll say a cable tester. So we can plug a cable into 2 ports on the block, and we can basically test if it's a good cable. So it'll also, I think, tell you how long the cable is roughly and things like that. So just kind of an extra tool we built in there.
Cool.
And then, of course, we have the actual media redundancy stuff like rapid spanning tree and things like that. But a few more bullet points, mostly unique. The wide voltage range. So we've placed these in mobile applications. I know voltage range is something that we haven't always been good about. A lot of times we require 18 volts with our IO blocks, and being able to get down to 8 volts is opens it up to a lot of new applications for us. So cut through forwarding. So your standard switches a lot of times are store and forward. Cut through forwarding is a way to increase speed and bandwidth. And if, say, the cut through forwarding doesn't keep up, it can actually revert back to its store and forward. So that happens at the firmware level. But yeah, just how it forwards the packets through the network. Port-based IP address allocation. That's something that you don't see on a lot of hardware. But you can basically have the switch push an IP address to a device. And of course, it's Turck designed, so that's always a plus. Applications. Pretty straightforward here. This is a managed switch. It's talking to a couple blocks on the network. No need to dwell on that one too much. Here's managed switch. So it looks like we got a bunch of isolated cells here, and it's basically just talking to each one of those cells. Each one would have its own IP subnet, but yet it's firewalling it and giving the plant IT network access to the OT network internally. Mobile equipment, of course, I just mentioned that with the wide voltage range. It's UV resistant. It has load dump protection, which is big in mobile markets. Of course, the protection class of IP69K. So good with, of course, your fast switching camera systems, et cetera, et cetera. Managed switch inter and intra-cell networking. So a lot of isolated cells. For instance, these cells might be just cookie cutter and they might all have the same equipment and they could essentially have all the same IP addresses and you'd be able to handle that isolated network, but yet still be able to tie it to a supervisory network using managed switches. And yeah, effective assembly cabling in the field. It's a block, it's connectorized, it's easy to deploy, easy to troubleshoot. You got the LEDs right out in the open for diagnostics, things like that. Kind of a tune we've been singing for years with our standard, remote IO blocks. So we have fast startup, under 150 milliseconds from when the switch powers on to when the switch is ready to communicate. I know this is something that we've had in all of our IO blocks as well, but I believe it's something we do generally better or faster than most people or most other vendors. Video streams, of course, I talked about that. We can run at wire speed. So, I mean, we're not going to be able to run a bunch of gigabit cameras here, but standard cameras into a gigabit backbone, running at wire speed, multicast support, things like that. So low latency, it's going to help in these camera systems and things like that. Just a little graphic of some high-speed backbone, bunch of different cells being networked together in a plant. Okay, so here's what I was talking about before. This is the network monitor. This is all in the web server, so it allows you to see what ports are up, what ports are down, the operating speed. It's going to tell you if there's any drop packets. It's going to tell you octets per second, packets per second, I believe. It's going to give you, like I said, all your counters, load management. So you'll be able to tell if a port is overloaded. Diagnostics and field bus monitoring, which says right here it's a future feature, but I believe we have those released. I at least have done some testing with those. If they're not released formally, then they're right there. So web-based configuration. I mean, it doesn't have command line. I know that was a traditional way to do it. More and more devices nowadays have the web server, but it seems it's a requirement, I feel like nowadays, where people just expect that they're going to get a web server. So with something like this, with all the configuration capabilities in this, it would be, I could see how it would be really tough without an integrated web server to program it.
Eric, so we don't only do have a web server on the block switches, but also on our TBEN blocks for I/O, correct?
Yep. All of our multi-protocol devices have an integrated web server now. And yeah, that's something when we design a new product at this point it just, like I said, it feels like a requirement. It has to have a web server. So, and yeah, the web server in all cases is accessed by typing in the IP address of the block into your web browser. So in the case of a managed switch, depending on what port you plug into, it could potentially be a different IP address. Or I'll say, unless you're using it as an unmanaged switch, it's always going to be a different IP address or a different subnet, I'll say at least, because each port on these have its own IP address. So, troubleshooting on the wire. Me and Chris have done some of this lately. Wireshark, if everybody's familiar with Wireshark, it's a way to actually sniff out the packets that are being sent over the network. To do that, to monitor those with your computer, you need to basically mirror a port. So, of course, we have port mirroring built into this, as most managed switches will. So we're able to select a port or multiple ports, and then, of course, a destination port, and it will mirror all the traffic over to that port so you can see what's going on the network. If you're getting weird network issues where you have devices dropping out, you have devices locking up, I mean, there's a million different network utilities out there nowadays, and a lot of network broadcasting and network management tools, and that can cause issues with automation devices. You know, we've seen it with our HMIs. So this is Wireshark is a tool to be able to tell what's happening when that crash happens. So, and to do that, of course, you need a managed switch. So, firewall, pretty self-explanatory, I guess. You can choose what traffic is allowed into your networks. In this case, on the right, looks like TCP protocol on ports 443 or port 80, which would be a web browser. So anything else, it's going to block or discard. You can set it up incoming, outgoing. You can set it by IP address. In this case, it's set to any IP address, and it's only looking at the port, the TCP port that the packets are going over. But yeah, it's a way to basically control what's able to come into your network. So IP addresses. Port-based IP address allocation, or we call it option 82 DHCP. Basically, you can set each port up to be able to push an IP address to a device. And of course, the device has to support it. I believe it uses DHCP on the device side. But yeah, so in the switch, you will decide what IP address that port needs to push, and as soon as you plug a device into it, it'll push it to the device. So we also have traditional DHCP client and server capabilities with both status and active leasing. That's not going to be quite as common on control networks. I would say the port-based IP address allocation is kind of like DHCP for control networks. Network address translation and port address translation. So this is how you're able to route between different IP subnets. Here's an example of it here, where they're taking traffic from an external network, the 12.222.2 network, and pushing it onto the control network, 192.168.1. In this case, this looks like it's strictly just to access the web browser of the devices. So any and all other traffic that you try and send to that device is going to get blocked and discarded unless you're working on TCP port 80, which is basically a web browser. And I should add, you know, for those of you not familiar with TCP ports, that's basically within an IP address on a device, there's multiple TCP ports depending on what the device is. There's standards out there that you can Google, standards for what ports are used by what services, whether it's like file transfer protocol, or even your, you know, PS5 has a specific port that it uses. So, and then there's of course a group of open TCP ports that can be used at a development level. So depending on what devices need to come through your firewall or through your NAT, you're going to need to know what port they operate on. Ethernet IP has a specific port, things like that. So network redundancy. So rapid spanning tree protocol or spanning tree protocol, been around for a long time, but it works. It's not quite as seamless as DLR or MRP. That's device level ring for Rockwell PLCs, or media redundancy protocol for Profinet, where you can build a ring of devices, and if a cable gets cut, it will self-heal. Similar idea with rapid spanning tree protocol, but just using a switch network basically. Changeovers, like I said, we've kind of been one of the leaders in Quick Connect, meaning we can get our blocks powered up and ready to communicate faster than almost anybody in the of all the other vendors.
Why is
VLAN.
that? Why is that, Eric?
Maybe it's the chipset we used in our multi-protocol. That'd be all I can think of. I mean, I remember Chris Vitale setting up a demo of that when I had first. Maybe I wasn't even a BDM yet. Maybe I was still in Chicago. But yeah, we're very fast being able to power up and link up on all of our switches, not only these managed switches, but just the switches inside our standard IO blocks. So that's really big in automotive, because for tool changers and things like that, they're cutting power, reestablishing power, and then they need to go as fast as possible. So I would probably attribute it to our MP1 chipset, which is the same reason we're able to do things like RG and beep, just because we have a chipset that has so much power. So that's what I suspect. LLDP, link layered discovery protocol. So this will basically go out and it'll identify what's all attached to the switch. So that way you can always monitor your network. I can't remember if this is included in our EDS file. It's been a while since I tested it, but that would also be nice for even the PLC to know what's connected. But yeah, I'll tell you how long it's been connected, things like that. MAC addresses, whatever. So in this case, it's even telling us our part numbers, hardware version, and software version of a TBEN 4IOL. So simple network management protocol. We support all three variations of it. That's just basically for upper level control network, not control networks, but IT networks, to be able to monitor devices, what's connected, what's not connected, things like that. Quality of service, that's basically just prioritization, so you can reduce bandwidth issues on your network. I won't dig too deep into that. IGMP, querying and snooping, we do with this, and that's to kind of control your multicast traffic. I talked about that a little bit ago, to where you maybe don't want to broadcast traffic to every port. It kind of is able to learn where that needs to go, what needs to get broadcasted to what ports, what devices. And NTP, so that's network time protocol. So it's able to be an NTP client or server. So it can not only get its time from an NTP server, but it can also send that time to other devices on the network. And that's all just for synchronization. And yeah, one thing I really wanted to get to here is, again, we have a USB port on here. So we can replace previous configurations. We can, similar to the safety block with the memory chip, we're able to replace devices easier using a USB, instead of having to have a computer there and go through all the daunting task of setting up the switch again. We can also export out of the web server and re-import it in there as well if you don't want to use the USB port. And that's it. That's all I got for you. We have a landing page for this, turck.com/switches. There is a brochure out there, and we have a YouTube video on it. Any questions?
Does Turck do systems engineering and support at end user clients when they want to do systems, or are we dependent upon the systems integrators to do that?
We've been getting into a little bit of that with TEPS, but probably not to the point where we're going to be as much as an integrator. So I always like for the customers to own their code. You know, I do write a lot of proof of concept code and things like that, but I do like to stay on the proof of concept, and because obviously what happens is you get so many programs out there and you end up having to maintain them, and it's a lot. So I like to always, even if I do proof of concept and it maybe even do more than that, I'll hand that off, train the customer on it, things like that. And I think that's kind of still where we're sitting with TEPS and our, call it integration services. We get a lot, I'll say we get quite a bit more into integration when it comes to Turck Volant systems, and that's our turnkey RFID systems. But TEPS is starting to do some of that stuff. It's kind of a case-to-case basis. We are set up to charge for that kind of thing. Charge for my time, charge for the company's time, things like that. We have a structure for that, but it's kind of like I said, case-by-case basis, whether we want to take that on for a specific project. But definitely something to bring to us and talk about. So,
on the product lines that you've spoken about today, Eric, are you finding at Turck that your revenue is coming mostly from OEMs or from the end user base?
Depends on territory, honestly, but OEM is probably the bigger part of our market. But yeah, like I said, as you move around the states, it's kind of different everywhere you go. But yeah, I'll say OEM, I guess.
But it's not out of the question to approach a high quality end user that is interested in upgrading to this level of technology on their plant floor.
Oh, absolutely. Yeah. Yeah. I mean, this stuff will drop into those end user applications as well. So, I mean, yeah. So yeah, I guess it's more where do we see most of our sales, but honestly, we can fit into any of the applications. I mean, except for maybe when you get up to the PLC level, as far as a plant with thousands and thousands of IO points. Maybe our PLCs won't be quite as robust as some of your more expensive Rockwells, when it comes to a mounted devices and things like that. But from a switch standpoint, I will leave IO-Link in there too. But also, yeah, remote IO stuff. Yeah, that's going to sit just fine out in those end user applications.
And one last question from me. I may have missed it, but do you offer a Class 1 Div 2, Class 1 Div 1 or ATEX rated product in this series?
All of our TBEM larges are Class 1 Div 2. I'll have to check on the switches. I'm not sure if we have Class 1 Div 2 on those yet, or even if it's applicable, because it's all Ethernet traffic, but it still does have a power connector. So, yeah, I might have to get back to you on that one. I'm not completely familiar with what we got on these as far as that goes, certifications and whatnot.
Well, thanks. Are there any other questions that you have for Eric this Monday morning? Well, we would like to thank you for taking your time to come and be our guest speaker today, Eric.
Absolutely.
Been a very nice presentation.
Yeah.
This will be available on the Western Automation YouTube channel. And I'm resolved to get caught up in transferring all these documents out of Teams to YouTube this week. I was caught up as of about a month and a half ago, so I only have a few to do yet. Next week, we start with a 2-week session where Eric Hodges is going to do, shall we say, a medium depth dive into motion control. Those of you that have wanted to find out, those of you that wanted to get a good background, a good foundation background on general motion control theory, Eric is an excellent teacher, has decades of experience, and I'm sure you will benefit from that. It's a good investment of 2 weeks of Monday morning with coffee. So we will see you next week. Eric, thanks once again. And it's 8:02, time to go to work. Everybody have a great week, and we'll see you next Monday.
Thanks,
Thank you,
everyone.
Eric. Thank you,
Have a
Pierce.
good week.
Thank you.
Thanks,
Hey,
guys.
Pierce, will you distribute this, please?
Yes, I will.
Thank you.